Okay, here, this is a 3D problem. It's kind of similar to the two-dimensional problems we've been working on, but it's just that there would be more equations and more steps to cover. Okay, let's get started. The unit vector is the position vector divided by the magnitude, and we need to find the forces in the x direction, y direction, and the z direction actually for all three of these forces here. So for the first one, the position vector is minus 6, 3. Well, because the second side is at 0, the difference would just be the same thing here. So let's have, well, before doing that, let's draw a free body diagram. We have something like this. This is the y, x, and z. So over here we have tension OA. Here we have tension OC. And over here we have tension OB. We also have a force going down with 6 kips. Okay, so here for TOA, the unit vector would simply be minus 6I minus 6J minus 3K divided by the magnitude. The magnitude is the square root of the sum of the squares of each of the components. So here we have minus 6 squared plus minus 6 squared plus minus 3 squared. It doesn't really matter to put the negative sign because the square still comes out to be positive, but just for, if you want to. And then the square root of everything here. So that would give us 9 in the denominator. So each one of these fractions would be over 9 minus 3. Yeah, kind of overlap this a bit. K over 9. Now we do the same thing for TOB and TOC as well. So this is OB is negative 2, 3, and 6. I equals to 3J plus 6K. Doing the same thing, divided by negative 2 squared plus 3 squared plus 6 squared, and the square root of that. So that should give us a 7 in the denominator. And then for TOC, also the same thing. 4I plus 3J. Well, the K is 0, so let's just put 0 here. So the square root will be 4 squared plus 3 squared. If you want to include 0 square root, and that comes out to be 4 over 5I plus 3 over 5K. And well, no, plus 3 over 5J actually. Second one is a J. And the last one is just 0K. So now we need to find the equations of all three. So for the first one, we would have the sum of forces in the x direction. So setting up the equation, we have sum of forces in the x direction equals to 0. So in the x direction here, we have this, and that, all three of them. So we start off by saying minus 6I 9 over 9 times TOA minus 2 over 7 TOB minus 6 minus 4 over 5. Is that minus or positive? It's positive. Positive 4 over 5 TOC equal to 0. This is the first equation. The I isn't really necessary over here, so we can take that off since we know we're summing about the x direction, so these are all in i's, so might as well take this off over here. Okay, and then for the next one we can do the sum of forces in the y direction, which will be the second one right here. It's not. Okay, there we go. Sum of forces in the y direction of those. So sum of forces in the y equal to 0. And then for the last one, we have the sum of forces in the z direction. So all of this. And not to forget, there's also a force going straight down right here, 6 kips. Well, since it's going down, that should be negative 6 kips. So the third equation will be sum of forces in the z direction equal to 0. Well, this is just a 0 TOC minus 6 equal to 0 because it's going down. Well, because this is a minus 6, we can move that to the other side to become a positive 6 equals 6. Well, here we have a system of 3 equations and 3 variables, and there are many ways of solving this. We can solve this by elimination, using matrices, whichever way you solve it, Cramer's rule. Whichever way you solve it, you should come out to be the same answer or close answers depending on your estimation or rounding errors that could have been accumulated throughout the calculation. So your final answer should be TOA is equals to 10.8 kips, TOB equals to 2.80 kips, and TOC equals to 10.0 kips.